Hello, welcome to the video notes for Lesson 4-5. This begins on page 20 in your notes packet. This lesson is operating or operations with numbers expressed in scientific notation. Now we're going to be dealing with multiplying and dividing word problems. In the last lesson it was addition and subtraction. Now we're going to be doing multiplying and dividing. So our lesson target, I can multiply and divide numbers in scientific notation to solve word problems. Alright? Now, before we actually do this with scientific notation type problems, we're going to do some multiplying word problems and some division word problems to get a little bit of practice and to remember what to do. So, page 20, we have some examples that we're going to do together that do not have scientific notation. Alright, so the first one. On average, a math student completes 153 practice assignments a school year. How many practice assignments are completed by 90 students in a year? Alright, so since we're dealing with word problems, I'm going to draw bucks down the side of my paper, and I'm going to use that for all these problems. So the box is going to be how many practice assignments are completed by 90 students in a year. I'm going to underline 153 practice assignments in a school year. Circle, I guess I'll circle the 90 because we're going to need that also. There's no unimportant information, so now we solve with a smile. Okay, so what do I do to answer this? So if a math student completes 153, 90 math students, well, I have to multiply. So 153 times 90. And we're going to multiply it vertically. So I'll multiply everything by 0, but that doesn't change anything. 0, 0, 0. Now I'm going to multiply each of these by 9. Remember, you got to move over one space. I put a 0 here. Some students put an X. Some students just move it over. 9 times 3 is 27. Carry the 2. 9 times 5 is 45. Plus 2 is 47. Carry the 4. 9 times 1 is 9, plus 4 is 13. So, we get our answer of 13,770. Alright, now, it's a word problem, so we need to write the answer in a complete sentence. So, on average, $90 students complete there are 13,770 assignments each year. Now, since I put my answer in a complete sentence, the label is basically part of the sentence. The label is assignments, so I don't need it next to my answer that I got when I multiplied, although some people like to do that too. That's fine. Alright, so there's a problem right below this that is another multiplying. The average height of a 6th grader is 4 feet. If 12 6th graders lay on the floor end to end, how long would the line be? There's your question. So I want you to solve this one on your own and answer it in a complete sentence. So use this space over here. Should be a pretty easy multiplication problem. Let's go down to the dividing or division. The length of a rectangle is 240 feet. the width of the rectangle is 30 feet. So let's underline and circle. How many times longer is the length of the rectangle? So, to find out how many times longer, we divide. So 240 divided by 30. Now some of you may know that answer in your head and you can write it down. If you don't know the answer, you're going to divide 240 by 30. Now, if you remember anything about long division, when we've got zeros like that, we can cross them out. How many times does 3 go into 24? It's 8. 8 times 3 is 24. Subtract and you get 0. So final answer of 8. Alright, so complete sentence. So how many times longer is the length of the rectangle? The length of the rectangle is 8 times longer than the width. Alright, so same thing as up above. I'm going to let you try the second problem on your own. It's another division problem. When you divide, remember you can cancel out zeros. That will make this one a little bit easier. You have some big numbers. 1,000 meters equals 1 kilometer. If Miss Kula drove 80,000 meters, how many kilometers did she drive? It's actually a pretty simple problem, but just make sure your final answer is a complete sentence. Okay, now over on to page 21. Now we're going to deal with this in scientific notation. And it's really not that bad. Again, we're going to be using bucks, so go ahead and write that along the side. I always do. Kind of a nice reminder of what we're doing. So, a carpet can contain millions of dust mites. Suppose the length of a dust mite is 2.5 times 10 to the minus 4. That's really, really small. If a carpet has 1 million dust mites, and they all crawled away single file, how long would the line be? There's our question. So we'll solve with a smile. Alright, now, we've got to think of a couple of things here. First, 1 million, what does that look like? Well, that's like this. 1 with 6 zeros. So really that's 1.0, or just 1 times 10 to the 6th power, which is also 1 times anything is just whatever that is, 10 to the 6th power. So watch what happens. So if one dust mite is 2.5 times 10 to the negative 4, we're going to take that 2.5 times 10 to the negative 4 and multiply that by 1,000,000. Instead of writing out 1,000,000, I'm going to write, and instead of writing all this, I'm just going to put 10 to the 6th. Because I don't need to put times 1 and then times 10 to the 6th. Now, I can combine these because they are exponential terms with the same base. So I really have 2.5 times 10 to the negative 4 plus 6. Negative 4 plus 6 is 2.5 times 10 squared. Now, if you want, this is okay, but you can expand this because it's not a bad number. Move the decimal 2 spaces to the right and you get 250. So, final answer is going to be in a complete sentence. How long would the line be? The line of dust mites would be would be 250, and notice your units, meters long. That's if you had 1,000,000 dust mites. Okay. Dividing. The biggest stars are known as red supergiants. One example, Betelgeuse, is about 300 million miles wide. 1 AU, that's astronomical units, is about 93 million miles. What is the width of Betelgeuse in AU? So there's our question. An astronomical units. Alright, so this is going to be a division problem. First, 300 million. Looks like this. And what is that in scientific notation? 3 times 10 to the 8th power. 93 million. What is that in scientific notation? 9.3 times 10 to the 7th power. So now I need to divide. I'm going to divide the actual 300 million miles by 93 to find out how many astronomical units it is. So that looks like this divided by this. So I'm dividing the miles by the AUs, and I get 3 times 10 to the 8th power over 9.3 times 10 to the 7th power. Now, this you would actually need a calculator for. You're going to need to divide 3 by 9.3. And if you were asked to do this on a test, you would be allowed to use a calculator. And I'm using a squiggly equal sign because it is not exactly equal to, but it is about 3.2. Now let's take care of the exponential terms. So I have 10 to the 8th divided by 10 to the 7th. That's really 10 to the 8th minus 7. And that's obviously 10 to the 1st power. So my answer is going to be 0.32 times 10 to the 1st power. Now this is not in good scientific notation, but really it doesn't matter because we're going to convert it to, or expand it to standard form anyways. 0.32 times 10 to the 1st power, I'm going to move this over 1, and I just end up with 3.2. So there's my answer. I'm going to put it in a complete sentence so I have a final answer. The width of Betelgeuse, or Betelgeuse, the width of Betelgeuse, kind of a funny name, is about, I'm using about because remember my answer is a rounded answer, 3.2 AU, which is astronomical units. Alright, there you go. So this will take some practice, but the skills are just multiplying and dividing. So if you had any trouble, go back and rewatch the video, or come see me for help. Good luck, and we'll see you in math.